NASA has, as of late, declared that the time has come to focus more on Venus, following new discoveries regarding the possibility of life on the planet. If you review NASA's historical records from the 1960s, you will find that the agency once referred to Venus as a planet from hell. In comparison, Mars had garnered attention as a promising target for exploration. Such harsh descriptions of distant planets were common during the intense space race era, a time when the Soviet Union was also heavily involved in sending costly missions to Venus, a planet that appeared nearly devoid of any potential for supporting life. Despite this, the Soviet space program did not abandon its Venera missions until the dissolution of the Soviet Union. Astrophysicist Neil deGrasse Tyson has played a vital role in helping us understand why they were so fascinated by Venus. Join us as we explore the declassified images of Venus captured by the Soviet Union. The collapse of the Soviet Union was groundbreaking for numerous reasons. Not only did it alter the global political landscape, but it also concealed many secrets. The Soviet Union was renowned for its secrecy, from operating one of the most sophisticated intelligence agencies in the world to staying silent about potential extraterrestrial encounters. Consequently, the former superpower kept various secrets hidden. Before the United States took the lead in planetary exploration, the Soviet Union was at the forefront of the space race. While the U.S. space program had both successes and failures, its primary focus remained on Venus, the mysterious and hostile planet. In Russian, Venus is called Venera, which also became the name of the Soviet mission that lasted from 1961 to 1983. This occurred during the same period that the U.S. was focused on reaching the moon. The Soviets strategically chose to concentrate their resources on Venus during the space race. It is not entirely surprising that the Soviet Union invested so much in Venus. Were they considering the planet as a potential site for a military base? Or were they perhaps exploring the possibility of colonization? After investigating the planet for any signs of life, the exact reasons behind their intense focus on Venus remain unclear. The Soviet Union was deeply involved in the Cold War, and many of their objectives were kept secret. In fact, much of what we know about their Venus missions comes from declassified or unarchived reports. Even then, pinpointing the true motivations behind their relentless efforts is challenging. The Soviets didn't just land on Venus once, twice, or 3 times. In total, they launched 28 rockets targeting the planet, with 13 successfully entering Venus' atmosphere. Of these, 8 missions managed to land successfully. These ambitious and complex missions positioned the Soviet Union as a leader in space exploration. While the U.S. was a close competitor, its focus was more on satellite technology and innovative infrastructure. In contrast, the Soviets were more dedicated to investigating the potential for life on distant planets. Their fixation on Venus stemmed from their quest for scientific knowledge and technological superiority. Most history books may not highlight this, but the Soviet space program was the first to send a probe into the atmosphere of a planet beyond Earth. It was also the first nation to achieve a soft landing on another planet, and the first to send back images and audio recordings from another planet's surface. While these remarkable accomplishments are often overshadowed by later American achievements, they were significant milestones in space exploration. In 1992, the Soviet Space Agency was officially dissolved following the USSR's collapse and was later re-established under the new Russian name, Roscosmos. Tragically, many historical records were lost or destroyed during this transition, which is why some aspects of the Soviet space program remain shrouded in mystery. Although we may never fully understand why the Soviets launched so many spacecraft into Venus' atmosphere, it is likely that their decision was influenced by cost-effectiveness rather than scientific curiosity. While the Soviet Union was undoubtedly interested in exploring Venus, they were also searching for the presence of water, solar radiation, and other environmental conditions. Without these missions, it would have been difficult for scientists to gain insights into Venus' extreme temperatures and dense atmosphere. Today, many cosmologists still argue that Venus is too hostile to support life. With temperatures hot enough to melt lead and an atmosphere dense with carbon dioxide, it's easy to dismiss the possibility of life on Venus. However, to overlook the pioneering efforts of the Soviet space program is to ignore an important chapter in history. For the Soviets, Venus was worth exploring, even if only as part of their broader goal to fuel the space race. Examining planets like Mars was not entirely out of the question, but it was a much more expensive undertaking than launching missions to Venus. The vast distance between Earth and other celestial bodies played a key role in determining where to focus resources. Venus, on average, is only 40 million kilometers away from Earth, whereas Mars is about 250 million kilometers away. This significant difference in distance is a major factor behind the high costs of Mars exploration. Furthermore, the United States' global economic strength made exploring Mars more feasible for them than for the Soviet Union. Some reports suggest that Soviet missions to Venus were inconsistent and faced significant technical challenges. Many of their spacecraft were not built to cover such large interplanetary distances. Additionally, there were several instances where communication was lost with the rockets. Given these obstacles, it makes sense that the Soviet space program would choose to focus on a closer planet that offered a better chance of success. However, focusing only on the technical setbacks overlooks the larger story of the Venera missions. When the Soviets began launching missions to Venus, the United States was still largely focused on reaching the moon. NASA's Venus missions during the 1960s were plagued by failures, which led to the phenomenon known as the Venus curse. Every time NASA launched a probe toward Venus, it ended in failure. This was when the Soviet Union saw an opportunity to capitalize on America's struggles and gain a significant victory in the space race. The Soviets accelerated their efforts to explore Venus, seeing the planet as a key milestone in the competition for space. Despite their limited resources, the Soviets continued launching a series of successful missions to Venus, while the U.S. focused on the moon. The hostile planet label was attached to Venus in popular media, often used by the U.S. to downplay the Soviet achievements. This negative portrayal of Venus didn't deter the Soviet space program, however. Their goal was to demonstrate their superiority over the U.S. Although the Soviet Union's Venus missions are not as widely recognized today, they were highly ambitious and advanced for their time. These missions showcased the Soviet Union's technological ingenuity, determination, and willingness to venture into the unknown despite overwhelming odds. Each new mission brought back valuable data about Venus' atmospheric composition, surface conditions, and environmental factors. The Soviets were the first to confirm that Venus' surface was incredibly hot and covered with volcanic activity, shedding light on why the planet's environment was so inhospitable. One of the most significant achievements of the Venera program was the first-ever image sent back from the surface of another planet. The Venera 9 spacecraft, which landed on Venus in 1975, captured black-and-white photographs of the rocky terrain, giving humanity its first glimpse of the planet's surface. These images were groundbreaking and marked a pivotal moment in planetary science. Despite these successes, the challenges of exploring Venus were immense. The planet's thick atmosphere, composed primarily of carbon dioxide, created crushing pressures and temperatures exceeding 900 degrees Fahrenheit, 475 degrees Celsius. This hostile environment destroyed most spacecraft within hours of landing, but the Soviets continued to improve their designs. By the time of Venera 13 in 1982, their landers could survive for over 2 hours, transmitting unprecedented amounts of data back to Earth. While the Soviet Union's Venus program set new standards for space exploration, it also highlighted the limitations of human technology when faced with the extremes of our solar system. The harsh conditions of Venus remain a barrier to exploration even today. However, the lessons learned from the Venera missions have influenced modern spacecraft design and deepened our understanding of planetary atmospheres. As interest in Venus resurges in the 21st century, scientists are revisiting the data collected by the Soviets. Recent discoveries, such as the detection of potential phosphine gas in Venus' atmosphere, have reignited debates about the possibility of microbial life on the planet. Although the Soviet missions did not focus explicitly on finding life, their detailed observations laid the groundwork for these modern investigations. NASA, along with other space agencies like the European Space Agency, ESA, and India's ISRO, has announced plans to explore Venus in the coming decades. Missions such as NASA's Da Vinci Plus and Veritas aim to study the planet's geology, atmosphere, and history. These efforts echo the spirit of the Venera program, which sought to uncover the mysteries of a world so different from our own. In many ways, the legacy of the Soviet Union's Venus exploration lives on. It serves as a reminder of humanity's insatiable curiosity and the drive to push beyond our limits. Venus, once deemed a hellish planet, may yet hold secrets that could reshape our understanding of life in the universe. And while the Soviet Union no longer exists, its contributions to space exploration remain an enduring testament to human ingenuity and perseverance. The Venera missions denoted the start of the space age. Beginning during the 1950s, the Soviets fostered the innovation expected to send shuttles to Venus. Over the following 30 years, they assembled and launched a progression of interplanetary tests as a component of the Venera program. During this period, the Soviet Union advanced its assets, making huge advancements in space exploration. By the mid-1960s, the Soviets had progressed far enough to launch Venera 3, the first artificial probe to enter Venus' atmosphere and make contact with the planet's surface. This achievement escalated the space race between the two superpowers. Unlike the United States, which often struggled with its Venus missions, the Soviet program made steady progress despite some technical setbacks. The USSR's ability to design and launch advanced rockets allowed them to continue achieving milestones, even as NASA faced challenges with its Venus missions. During the 1970s, the Soviets launched two probes, Venera 4 and Venera 5, marking one of the most exciting decades in space exploration. These dual launches enabled the Soviets to gather data from Venus' atmosphere and surface. Venera 4's success led to the development of more refined spacecraft, including Venera 5, which was designed to collect unique information about Venus conditions. The 1970s marked the pinnacle of the Soviet Union's Venera program. Venera 7, launched in 1970, was the first spacecraft to transmit data from another planet's surface, providing crucial information about Venus temperature and pressure. Later missions, such as Venera 13, captured color panoramic images of Venus' surface, offering unprecedented insights into its geology. Despite some failures, the Venera missions were instrumental in advancing our understanding of Venus and space exploration as a whole. During the 1980s, Venera 13 surpassed previous missions in complexity, capturing detailed images of the planet's surface. When the Soviet Union concluded its operations in the early 1990s, the Venera program had achieved far more than anyone had anticipated. The legacy of the Venera missions continues today as Roscosmos and NASA prepare for the joint Venera D mission, scheduled for the late 2020s or early 2030s. This new mission aims to explore Venus' atmosphere, geology, and history in hopes of uncovering signs of past or present habitability. The Venera missions pave the way for future missions to Venus, Mars, and beyond. Their contributions continue to shape the future of space exploration. The forthcoming Venera D mission, a collaboration between Roscosmos and NASA, marks an exciting new chapter in the ongoing exploration of Venus. Set to launch in the late 2020s or early 2030s, this mission will focus on studying the planet's atmosphere, geological history, and potential signs of habitability. The spacecraft will be equipped with an orbiter, a lander, and possibly an inflatable structure designed to explore Venus in exceptional detail. The Venera D mission not only aims to enhance our understanding of Venus, but also underscores the enduring legacy of the Soviet-era Venera program, one of the most ambitious and significant space exploration endeavors ever undertaken. As we look ahead, the lessons learned from the Venera missions remain relevant to current and future planetary exploration efforts. The technological advancements achieved by the Soviet space program, such as the development of robust materials capable of withstanding extreme temperatures and pressures, have been crucial for subsequent missions to Venus, Mars, and other planets in our solar system. These innovations in spacecraft design and instrumentation laid the foundation for modern space exploration and continue to inform mission planning, technological development, and operational strategies. The impact of the Venera program extends beyond the scientific and technological domains. During the Cold War, the space race was not just about scientific achievement, but also a means of asserting ideological superiority. The success of the Venera missions demonstrated the Soviet Union's technological capabilities and marked a significant milestone in its competition with the United States. The global community closely followed these achievements, recognizing the Venera missions as a vital part of humanity's expanding understanding of the universe. Each milestone, such as Venera 7's soft landing on Venus in 1970, was not only a scientific triumph but also a powerful political statement. Despite the challenges of operating in Venus' extreme environment, the Soviet space program's determination and ingenuity allowed them to overcome technical obstacles. Operating in Venus' hostile conditions, such as extreme temperatures of up to 450 degrees Celsius (842 degrees Fahrenheit), immense atmospheric pressure, and a dense, corrosive atmosphere composed mainly of sulfuric acid clouds, presented enormous challenges. These factors made it incredibly difficult for spacecraft to survive long enough to collect meaningful data. Nevertheless, the persistence and creativity of Soviet scientists and engineers were key to overcoming these challenges, enabling the successful collection of critical data about Venus' surface and atmosphere. The achievements of the Venera missions were instrumental in advancing our understanding of Venus' inhospitable conditions, from its scorching surface temperatures to its toxic atmosphere. These missions provided invaluable insights into the planet's extreme climate, dominated by carbon dioxide, and its geological features, including volcanic plains and mountainous terrain. The panoramic images captured by later missions, such as Venera 13 and Venera 14, furthered our understanding of Venus' surface composition, shedding light on its geological history and possible past volcanic activity. One of the most significant contributions of the Venera missions was their ability to capture the first-ever images of Venus' surface, offering a glimpse into a world previously hidden from view. The success of the Venera program proved that it was possible to gather meaningful scientific data from Venus, even in such a hostile environment. These photographs revealed a rugged alien landscape vastly different from anything on Earth. The success of the Venera missions demonstrated that despite the harsh conditions, valuable data could be collected, pushing the boundaries of human knowledge and expanding our understanding of the solar system. However, not all missions were successful. Some Soviet spacecraft failed to reach Venus or experienced technical glitches that prevented them from transmitting data back to Earth. The challenges of working in such extreme conditions, combined with the technological limitations of the time, meant that some missions did not achieve their objectives. Nonetheless, the determination of the Soviet space program, in the face of these setbacks, is a testament to the dedication and resilience of the scientists and engineers involved in the Venera project. The Venera missions not only expanded humanity's knowledge of Venus, but also laid a foundation for future planetary exploration. These missions showcased the ingenuity of spacecraft engineering, including innovations in thermal protection systems, robust instrumentation, and advanced communication technologies. Such breakthroughs were pivotal in enabling spacecraft to survive and transmit data from the harsh environments of other planets. The panoramic images, atmospheric composition data, and surface pressure measurements collected by the Venera program have informed subsequent missions to Venus and remain valuable even today. For instance, modern space agencies often reference the data from Venera to develop new tools and strategies for exploring planets with extreme environments, such as Venus and exoplanets with similar conditions. While the Venera missions marked extraordinary progress, they also highlighted the inherent challenges of interplanetary exploration. Many early probes encountered issues such as system failures during launch, navigation errors, or malfunctions upon arrival at Venus. These setbacks were not unique to the Soviet program. They were a natural part of humanity's learning curve in understanding the complexities of space exploration. The lessons learned from these difficulties contributed to refining spacecraft designs and improving mission planning for the future. The legacy of the Venera program is not only scientific, but also symbolic of the collaborative spirit that space exploration fosters. While the program began during the competitive era of the Cold War, Its achievements are now celebrated globally as a testament to human determination and creativity. Today, with international partnerships like the upcoming Venera mission, the exploration of Venus represents a unifying effort to uncover the mysteries of our neighboring planet. The future of Venus exploration. Building on the Venera program's legacy, the next generation of Venus missions aims to answer pressing questions about the planet's history and potential habitability. Venus is often referred to as Earth's twin due to its similar size and proximity, yet its extreme environment is a stark contrast to our own planet. Understanding how Venus became a hostile world with runaway greenhouse effects can provide critical insights into planetary evolution, climate change, and even the conditions that make a planet habitable. The joint Venera mission by Roscosmos and NASA represents a new era of international cooperation. Equipped with cutting-edge technology, this mission will deploy multiple platforms, including a durable lander to study surface conditions, an orbiter to analyze atmospheric composition, and possibly an aerial platform to explore the thick clouds that shroud Venus. The mission's objectives include determining whether Venus ever had liquid water on its surface, assessing its volcanic activity, and searching for signs of past or present microbial life in its atmosphere. In addition to Venera, other space agencies have announced ambitious plans for Venus exploration. NASA's Da Vinci Plus and Veritas missions, set to launch later this decade, aim to complement the data from the Venera program by providing high-resolution maps of Venus' surface and detailed studies of its atmosphere. Similarly, the European Space Agency's Envision mission will investigate Venus geology and monitor for active geological processes. These missions promise to deepen our understanding of Venus, but they also serve a broader purpose: preparing humanity for the exploration of more distant worlds. The technologies and techniques developed for Venus exploration, such as advanced heat-resistant materials and autonomous navigation systems, will be essential for future missions to the outer planets and their moons. Reflecting on the Venera legacy. The Venera missions stand as a testament to the power of human curiosity and perseverance. They pushed the boundaries of what was technologically possible at the time and demonstrated that even the most challenging goals could be achieved with dedication and ingenuity. Despite operating under the constraints of Cold War politics, the program managed to achieve milestones that continue to inspire scientists, engineers, and dreamers worldwide. The data gathered by Venera not only provided a glimpse into Venus' hostile environment, but also raised new questions that drive current and future exploration efforts. What caused Venus' climate to diverge so drastically from Earth's? Could microbial life exist in its acidic clouds? What can Venus teach us about the fate of Earth's climate? As humanity prepares for the next chapter in space exploration, the lessons from Venera remind us that exploration is not just about reaching new frontiers. It's about understanding our place in the universe. By studying planets like Venus, we gain insights into the processes that shape planetary systems, the potential for life elsewhere, and the resilience of the human spirit in the face of adversity. The Venera program was more than a series of space missions. It was a bold declaration that no challenge is insurmountable with science and determination. Its legacy will continue to shape humanity's journey into the cosmos for generations to come.